Hello everyone, this is Sravanthi, Assistant Professor, Department of Chemistry, in Institute of Aeronautical Engineering. Today we are going to discuss about the topic is external treatment of water. In this we are going to discuss ion exchange method or ion exchange process. So what is the meaning of external treatment of water? Generally hard water converted to soft water. Hard water means it containing calcium, magnesium ions of chloride, sulfate, nitrates, bicarbonates, etc. present in water is called hard water. So it is purified and hard water converted into soft water by ion exchange method. So externally we have added some resins. So we have purified this hard water converted to soft water. This is called external treatment of water. So after purified this water we can use in boilers. So in this external treatment of water, mainly discussed about ion exchange process. So many methods are employed for this softening of water. That means hard water converted to soft water by using different methods like lime soda process, geolite process, ion exchange method. So many methods are employed for this process. That means hard water converted to soft water. But what is the main advantages of ion exchange method compared to lime soda method or geolite process? So what is the main difference between this process? This is ion exchange method is more preferable because lime soda process and geolite process also useful for hard water converted to soft water, but we cannot remove any minerals. Only in those processes we can remove hardness causing ions like calcium, magnesium, bicarbonates, chlorides, sulfates, etc. But in this ion exchange method, we can remove hardness causing ions and also we can remove minerals also like sodium, potassium salts. Okay, so that is the main difference between remaining softening methods and this ion exchange method. So this ion exchange method is also called as demineralization process or deionization process. It is also called as demineralization process. So in this process, it is mainly carried out by using resins. So these resins are in this method, ion exchange method, it is also called as demineralization process. That means it can remove hardness causing ions and also we can remove minerals. So that's why this method is called demineralization process. So this method is carried out by using resins. Resins means it is highly insoluble. Resins are highly insoluble and cross-linking high molecular weight organic polymers. Resins are high molecular weight cross-linking organic polymers. These are highly insoluble. And these resins are having microporous structure. This is the resin structure. So these resins are having micropores. So these pores are mainly used for holding the hardness causing ions or minerals which are present in water. So in this way, these resins remove all the hardness causing ions and minerals which are present in water. So resins plays an important role in this ion exchange method. So in this purpose, we are using two types of resins, cation exchange resin, anion exchange resins. So resins are high molecular weight cross-linking organic polymers and these are highly insoluble and these are having microporous structure. These pores and it is having some small pores. These are used for holding the cations or anions which are present in this water. That means hardness causing ions or minerals, etc. So in this case, resins, generally we are using two types of resins in this ion exchange method. One is cation exchange resin and second one is anion exchange resin. So cation exchange resin means it containing basic function group. So here, for example, see resins with acidic function group, for example. So in this case, it's capable of exchanging their H plus ions into the water. The resins are having acidic functional group. So in this case, these resins are capable of exchanging their H plus ions into the water and absorbs all the cations present in water. If in case resins containing basic functional groups. So in this case, they are capable of exchanging their OH minus ions into the water and absorbs all the anions which are present in water. So in this method, we are using generally two types of resins: cation exchange resin, anion exchange resin. And this resin is plays an important role in this ion exchange method. Then this method is also called as demineralization process. So first we discuss cation exchange resin. So resin means what? It is a cross-linking high molecular weight organic polymer. So in this process, first we are using cation exchange resin. So what is the functioning of cation exchange resin? So cation exchange resins are generally styrene divinyl benzene copolymers. Styrene divinyl benzene copolymers. So which contains acidic functional group. Cation exchange resin, it containing acidic functional group like COOH, carboxylic acid, sulfonic acid, SO3H functional groups, which are responsible for exchanging their H plus ions into the water and capable of absorb which type of cation present in water. For example, here cation exchange resin, it is represented as RH, RH or RH2. So this is a cation exchange resin. For example, here this is the cation exchange resin. In this hard water, if in case it's present hardness causing ions, here it's present, for example, calcium chloride, hardness causing ions present in this water. So what is the functioning of a cation exchange resin? It containing generally acidic functional group like carboxylic acid or sulfonic acid, etc. So it is capable of exchanging their H plus ions into the water and absorbs all the cations which are present in water. For example, calcium, magnesium and sodium, potassium. So which type of cations present in water? It will be absorbed by cation exchange resin and it gives the H plus ions into the water. This is the main functioning of cation exchange resin. You see this is the cation exchange resin. When we are adding water in this, so what is the functioning of this resin? Cation exchange resin absorbs all the cations present in water and gives their H plus ions into the water, and coming out of the water is soft water. So for example, here see RH, cation exchange resin, symbol RH. So if in case in this water is present hardness causing ions like calcium chloride. So this cation exchange resin absorbs cations in this calcium chloride, Ca plus Cl2 minus. So what is the function of cation exchange resin? It absorbs cations which are present in water. For example, in this calcium chloride, calcium cations absorbed by cation exchange resin and it gives H plus ions into the water. So here what is the final reaction? R2Ca plus HCl. So coming out of the water is present H plus ions and anions. And the same way here 2RH, it is the cation exchange resin. If in case in this water magnesium chloride present in this water. So cation exchange resin absorbs magnesium cations and gives their H plus ions into the water. So coming out of the water it containing H plus ions and anions because cations are absorbed by cation exchange resin. For example, here in this water it's present magnesium sulfate. So cation exchange resin absorbs magnesium cations and gives H plus ions into the water. So in this water coming out of the water is present H plus ions and sulfates, sulfate anions present in water. For example, calcium sulfate present in water. So calcium ions absorbed by cation exchange resin and it gives H plus ions into the water. So finally coming out of the water it containing H plus ions and sulfates. So main thing is cation exchange resin. It absorbs all the cations which are present in water and it gives their H plus ions into the water. This is the main function of cation exchange resin. Next, anion exchange resin. So in this ion exchange method, in this process generally we are using two types of resins: cation exchange resin, anion exchange resin. So what is the functioning of anion exchange resin? So anion exchange resin, its function group is ROH. ROH. Anion exchange resins. Generally, these resins are phenol formaldehyde resins or amine formaldehyde copolymers. So anion exchange resins are phenol formaldehyde resins or amine formaldehyde copolymers, which contains basic functional groups like amine or OH groups like NH2 or OH functional groups. These resins containing basic functional groups like amine or hydroxy functional groups, and it is responsible for exchanging their OH minus ions into the water and absorbs all the anions which are present in water. So what is the functioning of anion exchange resin? It containing basic functional group like OH or NH2, and it absorbs all the anions which are present in water and it gives their OH minus ions into the water. So for example here ROH, it is a symbol of anion exchange resin in the coming out water previously discussed already. So in this water it's present, for example, calcium chloride. Cation exchange resin absorbs calcium. So coming out of the water it presents only H plus ions and Cl minus ions. So the Cl minus ions absorbed by anion exchange resin. See here, the Cl minus ions absorbed by anion exchange resin. Finally, coming out of the water, it is completely free from anions and cations. Only it's present H plus and OH minus ions and a pure water present coming out of the water. It completely remove hardness causing ions and also minerals also. Only it's present H plus and OH minus ions. That's why this method is called demineralization process or deionized process. So for example here ROH, anion exchange resin, coming out of the water is present after completing this cation exchange resin functioning. So it is present H plus ions and sulfates. So this anion exchange resin absorbs the sulfates. So it completely removes cations and anions in this finally giving output water. And one more example here. For example, in this water is present H2CO3. So anion exchange resin absorbs the CO3 minus anions and gives their OH minus ions into the water. So in this anion exchange resin, it containing mainly basic functional group like OH and NH2, and its functioning is capable of exchanging their OH minus ions into the water and absorbs all the anions which are present in water. See the image here also. So it absorbs all the anions present in water and it gives capable of their OH minus ions into the water. So this is equipment which is used for softening demineralization process or ion exchange method. So in this case first hard water. That means hard water means it containing minerals and also hardness causing ions like calcium, magnesium, bicarbonates, chlorides, sulfates, etc. present in this water. So we can purify it. That means hard water converted to soft water. So by using this ion exchange method. So when we pass this hard water in this cation exchange column, this is the cation exchange column. So hard water first passed into this cation exchange column. In this cation exchange column, it's present, this is the gravel bed, and also it's present cation exchange resin. It's present cation exchange resin. Symbol is RH. So what is the functioning of cation exchange resin? It absorbs all the cations like calcium, magnesium, sodium, potassium, etc. It absorbs all the cations which are present in water and it gives their H plus ions into the water. Next, this water is after completing this cation exchange resin treatment, then this water is passed into anion exchange column. This is the anion exchange column. So in this anion exchange column, it's present gravel and as well as anion exchange resin. So what is the function of anion exchange resin? It absorbs when we pass this after completing this cation exchange resin treatment. This water is passed through this passed in this anion exchange column. In this column already is present anion exchange resin. This resin is absorbs all the anions like bicarbonates, chlorides, sulfates which are present in water. So it absorbs all the anions present in water and it gives their OH minus ions into the water, capable of exchanging their OH minus ions into the water. So coming out of the water, it is completely free from hardness causing ions and also it is completely free from minerals. So this water is called soft water and it is also called as demineralization process. Demineralize process. So here, what is the use of this acid and base? If in case this cation exchange resin is exhausted, cation exchange resin is exhausted. So in this case, this cation exchange resin is regenerated by using dilute acid like HCl or H2SO4. And here also same, if in case anion exchange resin is exhausted, anion exchange resin is exhausted. So it can be regenerated by using base dilute NaOH. So this process. So in this case, first ion exchange process, hot water is allowed to the cation exchange column. In this cation exchange column, already is present cation exchange resin. It absorbs all the cations like calcium, magnesium which are present in water and it gives their H plus ions into the water. See here, this is a cation exchange resin. When we pass raw water in this cation exchange column, it absorbs all the cations which are present in water and it gives the H plus ions into the water. Next, this water is passed through this anion exchange column. So in this anion exchange column, it's present anion exchange resin. It absorbs all the anions which are present in water and it gives their OH minus ions into the water, capable of exchanging their OH minus ions into the water. Thus, by passing hard water through cation, hardness is absorbed by the following reaction. That means here H plus and OH minus ions thus released in water from respective cation and anion exchange columns. From the cation and anion exchange columns, finally it gives coming out of the water, it's present only H plus and OH minus ions. So then it combine to produce water molecules. So in this cation exchange column, it gives H plus ions and anion exchange column, it gives OH minus ions. So coming out of the water, it's present only, it produces H2O. Pure water, there is completely free from hardness causing ions and minerals. So the water coming out of from the exchanger is ion free from anions and cations. This water hardness is 0. So it doesn't contain any hardness causing ions and minerals. So hardness of this coming out of the water which is released from this ion exchange method is 0. Hardness is obtained. So just now already we discussed how can we regenerate this cation exchange resin and anion exchange resin. See here, when the cation exchange resin loses capacity of producing H plus ions, that means it is completely exhausted. If in case cation exchange resin is exhausted, that means loses capability of producing H plus ions, or otherwise anion exchange resin loses capacity of producing OH minus ions. Anion exchange resin also loses capacity of producing OH minus ions. So in this case, that means cation exchange resin or anion exchange resin is exhausted. So in this case, how can we regenerate this cation exchange resin and anion exchange resin? So the cation exchange resin is regenerated by passing it through the acid, dilute acid like HCl or H2SO4. In this case, for example, reverse reaction. So cation exchange resin R2Ca. So it can be regenerated by adding HCl, by passing HCl or H2SO4. So in this case, this cation exchange resin RH2 or RH, it can be regenerated, reproducing H plus ions into the water. And for example, this cation exchange resin regenerated by using sulfuric acid dilute. sulfuric acid. In this case also, this cation exchange resin is regenerated to reproduce H plus ions into the water. And for example here, anion exchange resin is exhausted to losses of producing OH minus. So how can we regenerate this anion exchange resin? By passing NaOH, by passing dilute solution of NaOH. So here R2SO4 anion exchange resin, it can be regenerated by adding dilute NaOH. So it regenerated ROH. Anion exchange resin is regenerated. Here also same, by passing NaOH. So in this case also it ROH, anion exchange resin is regenerated. Here also by passing NaOH to RHCO3. Here also it produces anion exchange resin regenerated by passing dilute acid. So what are the merits of ion exchange process? So what is the main difference between remaining softening methods and this ion exchange method? Remaining, for example, lime soda method, rheolite process, these methods also used for hard water converted to soft water. But it remove only hardness causing ions in this lime soda process and rheolite process. But in this ion exchange method, it can remove completely hardness causing ions and also minerals. It is completely free from all the cations and anions. Only it's present H plus and OH minus ions. That is the main difference between remaining softening methods and ion exchange methods. So what are the merits of ion exchange process? So in this process, it can be used to softening highly acidic. This method is also used for highly acidic or alkaline water. Highly acidic or alkaline water we can treat it in this ion exchange method. And it produces water. It produces soft water is hardness is very low, to 0 to 2 ppm, to below 2 ppm. It produces very less hardness of water. And it is very good for treating water for use in high pressure boilers. Generally in boiler water, if in case we are using hard water, any water, if in case in this hard water, hardness causing ions present. So in this case, it occurs boiler troubles. So many troubles creating in this boilers. Generally, these boilers used in industries for steam generation purpose, which is used for power generation. So if in case hardness causing ions present in this water, it creates so many troubles in this boilers, steam generation purpose. It creating so many troubles like priming, foaming, castic embrittlement, or sludge or scales. So we can avoid that type of problems by using this ion exchange method, because it completely remove all the hardness causing ions. Also it removes minerals. So there is no problem in this boilers. This water is most preferable in this high pressure boilers. It avoiding all the boiler troubles. These are the main merits of ion exchange process. One is it is mainly used for, it is also used for highly acidic or alkaline water. We can treat it in this ion exchange method, and resulting water, softening water, hardness is very low. It is less than 2 ppm, and this water is more suitable for boilers, high pressure boilers, because it is completely free from hardness causing ions and minerals. Next, what are the demerits of ion exchange method? This equipment is costly and more expensive. Chemicals are needed. Ion exchange resins, cation exchange resin, anion exchange, it is highly expensive, which are used for this ion exchange process. So this equipment is costly and more expensive. Chemicals are needed or required for this process. And next one is, if water contains turbidity. Turbidity means impurities, contaminants or sediments which are present in water. So the output of the process reduced. If in case any turbidity or impurity present in this, the output of the process reduced. That means the turbidity must be below 10 ppm. Only this water only treated in this ion exchange method. If in case turbidity is more means it required sedimentation and coagulation for settlement of these sediments which are present in this water. After that only we can purify in this ion exchange process. So in this class we will learn what is external treatment of water, how can we purify this water by using ion exchange method, by using ion exchange resins, and what are the advantages, merits and demerits we learn in this class. I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.